Hey guys, I'm coming at you from my house. So I'm recording this lesson at my house, and my kids are home with me. So hopefully that doesn't bother you. Probably the next couple lessons will be that way as well. Just kind of a quick review. Remember, we're looking at solving quadratics. And so for here, we're going to have a word problem. So you're not going to necessarily have to write the equation. It'll probably be given to you, but you're going to have to be able to solve it and know what you're trying to find. So remember that we have our standard form is ax squared plus bx plus c is equal to 0. So remember, you have to have 0 on that one side. And then we have our different ways to solve the quadratic equation. So we are going to have, we have factoring. And then we also, which is not a fan, you're not a fan of it, but I'm going to show you something that you might become a fan of it. And then you also have the quadratic formula. And then you also have graphing. So you could graph these as well. And so remember, that's using Desmos, Desmos, Desmos.com/calculator. And that will be a nice little graphing feature for you there. All right, so even though the NBA gets postponed, we still have it here in our problem. After being fouled, Shaquille O'Neal gets one shot from the free throw line. And this is the equation which follows the height of the ball, which is h, and after so many seconds, which is t. So they want to know how high is the ball after 2 seconds. So you want to make sure you know where you're plugging in to. Is it h or is it t? Well, since we're talking about seconds, which is a reference to time, that is going to be plugged in for t. So I'm going to replace 2 everywhere I see t in my equation. That will give me the height, which is h. So I'm going to have h is equal to 5 times 2 minus 2 squared plus 4. So plugging that into your Desmos calculator, you can plug that in. Just don't plug in the h equals part. You just start with the 5. And so therefore you would get a height of 10 feet. The second question here says, when will the ball hit the ground? So you want to know when h, the height of the ball, is going to be on the ground. Well, the height at the ground is 0. So you're going to replace h here for 0. So I'm going to have 0 is equal to 5t minus t squared plus 4. So what you can do here, you can graph this and find the zeros, or you can use the quadratic formula. So that's what I'm going to use here. So that is going to be x equals negative b plus or minus the square root of b squared minus 4 times ac divided by 2a. So a is the number that's in front of x squared, or t squared in this instance, which is a -1. So don't forget about that negative sign there, minus negative, same thing. B is 5 because it's a number in front of just the regular x, or just t in this instance. And then c is that constant that doesn't have the variable with it. So those are all my variables there. So I'm going to go back and plug this in. So I'm going to have x is equal to -5 plus or minus the square root of 5 squared minus 4 times -1 times 4, and then divided by 2 times -1. So from here, I'm going to plug in this piece here underneath the square root sign. I'm going to get 41. So I have x is equal to -5 plus or minus the square root of 41 divided by -2. So this is where we split off and have 2 separate equations. So I'm going to have one equation where I have -5 plus the square root of 41 divided by -2. And then I'll also have another equation that says x is equal to -5. I'm going to drop the other one way down here. And so x is going to be equal to -5 minus the square root of 41 divided by -2. So then plugging that into my Desmos.com/calculator, you're going to get x is equal to -0.7 And then you're going to also get x is equal to 5.7. Now, this answer right here does not make sense because it has a negative time and you can't have negative time. So when does it hit the ground again? It would hit the ground basically again in the second part here. Now, it doesn't make sense for it to start on the ground because he's not shooting it from the ground. He's shooting it from above the ground, obviously. So that is why the negative piece doesn't make sense. All right, so second example here, we have an archer shoots an arrow into the air, and the equation is shown here. H is still the height of the arrow, but this time in meters, and then T is still the time in seconds. So it wants to know how high is the arrow after 2 seconds. So since seconds represents time, then I am going to plug in 2 for T. So 2 is going to replace T here and here. So, and they're asking how high. So they're saying, what is the height? So I'm going to have H is equal to 17 times 2 minus 5 times 2 squared. So after you plug that in, you're going to get 14. So the height is going to be 14 meters after 2 seconds. So it's like he's shooting it straight up in the air and then it's coming back down. Then it's asking when will it come back to the ground. So it's like this is kind of starting, well, we'll see. So when will it come back to the ground is the second question. So this is asking when. So what is the time when it will come back to the ground? So this is when H is equal to 0. So the height at the ground is 0. So therefore, I'm going to have 0 is equal to 17t minus 5t squared. Now, normally you don't like factoring. However, this works out really well for factoring because I can factor out a greatest common factor because I don't have a constant. I don't have this number out here like a c. So I can factor out a t. So this looks like this. T, which is 17 minus 5t, is equal to 0. Now I have my two factors that are equal to 0. That means either t is equal to 0, that's one of my factors, and then or 17 minus 5t is equal to 0, that is my second factor. So if it doesn't have a constant, you can factor out a greatest common factor, especially if both of them have to have a t, though. That does have to happen as well. Or I guess the other way, it'd have a constant because it doesn't have a t with it. So, but this does kind of work out really well as far as factoring goes with this. So either t is equal to 0, so that means that it is on the ground when time is equal to 0, which means they shot it from the ground. Doesn't make much sense, but we're rolling with it. And then I'm going to find out. So I'm going to solve for t here. So subtract 17 on each side. I'm going to come up here, and I have negative 5t is equal to negative 17. Divide by negative 5. And t is equal to 3.4. So at 3.4 seconds, it would come back and hit the ground. So, and this says, obviously, it says back to the ground. So again, they kind of they knew that it started at the ground. And then it says, when does it come back to the ground? So that's the second time it hits the ground. So a couple of things, solve these quadratics however you would like. It does not matter to me which way you decide. And I will be posting a short tutorial video on Desmos here in the next couple of days, so that way you can use that a little bit more efficiently.